All right.
Cool.
I think we're live. All right.
Alrighty.
Um, hey, hello to everyone at Data Ops Unleashed. I'm really excited about the conversation that we're about to get into. Just as some quick introductions, I am Abhi, a senior developer advocate at Airbyte, and with me is this is Jins. He is one of the most influential CTOs in the in his space. He's been revolutionizing the way that AgriDigital basically does implements their data architecture. He's made a lot of really interesting discoveries in a lot of this stuff we're going to get into today about like microservice data access, and he's overall just a really awesome guy. Jins, thanks for talking with me today.
No, thanks, mate. It's just really good to come here and chat to you guys as well. I really appreciate the quick intro as well.
Yeah, of course. And so I guess kind of just quickly jumping into this, I guess for people that don't know, I'm for people that don't know, what is AgriDigital, and and what are you trying to solve? What is the space that AgriDigital is trying to is trying to get
Yeah,
into?
yeah, it's a good question. Like, not many people know what we do, but we are quite impactful in a lot of the agriculture sector. So, AgriDigital, we provide and build supply chain software for everyone in the agricultural grain industry globally. So it's everyone from the farmer all the way down to the person eating the food at the end of the day. Um, what do we mean by supply chain software? Well, one of the things we realized was that our founders are all farmers, and they realized that to try and grow their businesses, it was hard because banks and access to capital was essentially non-existent. Um, Banks would try and make it very hard to try and give you the money in the first place. They want to securitize and collateralize everything you had personally, and it would take about 6 to 8 months to try and get a bank loan. If you think of farmers, they're just like small businesses, and they hold an asset. The asset being the grain, like wheat and corn,
Yeah.
and it could be worth couple $1 million every time they do a harvest. So we built this set of software that allows us to track quite literally the seedling all the way down to harvesting, into a logistics container, down to the actual final person that's purchasing it. And because we can see that, this is where the data play comes in. We then are able to provide what we call data-driven finance. And the data-driven finance part is about using all the data we have, behavioral, back-end data, industry data, and provide a financing score and an amount in real time. So it's an eligibility score. So we're like a unique blend of fintech meets agtech. And in Australia, we've done this quite successfully, and we're just launching in the United States. In Australia, we've already done $6 billion worth of grain, which is about 15% of the Australian market. $50 million worth of loans provided out. I've got 9,000 users, and so we needed something to help us with our data strategies because obviously we're trying to do this bigger and better.
Yeah, so I guess that kind of nicely segues into, you have this massive amount of data, and that you're trying to communicate, I guess, to your farmers, or you're trying to use to make decisions about basically instantly getting loans into farmers' hands. So there's this kind of big platform that you have to set up, and there's a lot of information. And we've talked before, and in one of those in a lot of those conversations, we talk about this thing called microservice data access, and basically accessing reference data that your system has to constantly call over and over again.
Yeah.
Yeah, look, can we, for I guess the attendees here, can we contextualize what that problem was at AgriDigital? What is the problem that you were trying to solve around that, and how did you go around implementing it, looking at the different types of data access that you had available to you?
Yeah, great question. So I joined AgriDigital about 18 months ago, just under 2 years. And the platform that I inherited was a platform about event-driven architecture, about microservices. It was trying to implement it all, but it wasn't really done properly. So if you think about a typical microservice pattern, you've got a microservice and its own database, and you typically would have another microservice talk to the other service A via a HTTP endpoint or a REST API call. Unfortunately, what we actually implemented in parts of our system was not that. It was actually we had multiple microservices talking to each other's databases directly, and that can cause a problem. Obviously, there's a lot of latency issues, there's a lot of concurrency issues, there's a lot of quality issues. So a service is updating something and another service is also updating that same data for some reason, which it shouldn't. It can cause trust in the supply chain and
Yeah.
trust in the data. And if you think about it then from a financing and accessibility perspective, yeah, it gets pretty hard to create a set of formulas or algorithms to try and create an assessment for financial abilities if you can't trust your own numbers. So that was sort of the position we were in. We had a ton of these microservices or supposed microservices out there in our system, but we had all of our, some of our microservices talking to each other directly rather than via the API sort of standard approach. So that got me thinking about, well, how can we do this better? Is it like why are we even having the discussion? Like why are we requesting the data in the first place? And that first question about why led to a discussion about the timeliness and the speed at which we need the information. So we have something called a reference service, which pulls in referential information around anything about commodities and pricing. And that information needs to be provided to all of our updated services, such as our deliveries and contracts and invoice payments and yada, yada, yada. It needs to be updated pretty real time. But what we were doing was, let's just say the invoices module or invoices microservice, it would call the reference database and create a cache and pull that out directly from that database and then put it into their own schema. But it was referencing and calling directly from the other microservice. And instead of having the ability to go and ask for it via an HTTP endpoint, it was going directly, and that was causing a lot of bottlenecks. So the desire was speed, and the desire was making sure that we had the latest information as much as possible. So I said to myself, well, how can we re-architect this? How can we make this so that, one, we can decouple our services, and two, we can actually make it easy for the data to be moved from one point to another point. And that's where Airbyte came into it.
Yeah, so I guess that leads us to what the tool you eventually I guess used for I guess populating the like the reference data, right? And um so I guess there's a bunch of different like tools you could have used to I guess to populate it. Why did you choose an ETL tool? I guess that's because I mean while it makes sense, like I guess that wouldn't be like I guess the first thing that people go to, right?
Yeah, so I think it comes down to the patterns of data access for microservices. I think there's three patterns. So there's full event-driven cache, partial event-driven cache, or like on-demand access. So if you think about what those are, so a like the event-driven cache approach is grabbing elements of that data periodically, either in totality from the database or in partiality, and moving it to the other services and having essentially a copy of it, a cache copy. And then the third is on-demand access, i.e. having every time something changes in one service, an event trigger with all the data that needs to be pushed, being pushed out to any subscribers. We realized because of the size of our reference data, we needed a full event-driven cache and a direct copy. So I evaluated a few tools. I looked at AWS's Glue services to be able to do an ETL movement across. I even utilized their RDS, I guess, duplication service, which doesn't actually do that well from my experiences. We used a lot. We looked at other things like Fivetran and other open source tools. I can't remember what it's called. What it's called again. But it just wasn't simple. And I came across Airbyte mainly because I saw a blog post about it, and it promised a very simple experience. Now, that's the primary reason why I used Airbyte, is the simplicity of it all. Like, quite literally, my junior engineer who actually helped me implement it was able to go and set up the server, point it to our database, and then to our databases, and then implement a instantaneous sync across. That was phenomenal. So we're now able to remove decouple our services, which is great. And all of a sudden, our backend data is now being updated, in our case, every 5 minutes to any services that need it. And that means there's a huge amount of trust, because we're just getting raw data from one and pushing it to the other. And that means the service that needs that data is doing the manipulation on their end. They're not requesting the manipulation done by the actual initial provider service. So that's one of the reasons why. Now, the other big thing is the cost. We've just finished a few cost exercises that do comparisons between, for example, doing this caching strategy with AWS Glue versus a caching strategy with Airbyte. And I can tell you that Airbyte does come out cheaper in the long term. So that does help out a lot, because as a startup as well, and as a company that's moving a ton of data, we need it to be cost effective.
Yeah, that makes a lot of sense. I guess to be a little more critical of Airbyte and of the own thing that I work for, like something that I think went into, I guess, choosing a solution was basically the amount of time that it takes in order to sync, right? If you're doing
Yep.
if you're doing these full transfers, and you're expecting full copies in your reference data cache, this could, I guess, be a bottleneck for like time sensitivity, right? So it's like if you're not moving that data fast enough into the reference cache, there's probably going to be some issues. Have you worked around any of these problems, or have you like address any of these issues? And how do you deal with time sensitivity with moving tons of data using the ETL pipelines?
Yeah, so there's two strategies that we use. If it's needed to be exactly real time, we don't do a caching approach, and we don't do a ETL approach. We actually have our services push event-driven information to any other services that are subscribed. That is the most real time we can get, and essentially, it's the moment it happens, it gets pushed across, and that works perfectly fine. For the large amounts of reference data being pushed from our reference services to a lot of other services themselves, what we do is we actually chunk them up, and we do delta changes, and we only update what needs to be done, and that reduces the amount of information that needs to get pushed across. It's the reason why we can still do data syncs every 5 minutes, and a 5-minute interval for us is actually quite nice, because it allows us to keep up to date with information without having to have our services go down or request it every 5 minutes themselves. And if we think about it, the reference information isn't being updated every second. It's being updated, a couple of times a day, and we're just making sure that that latest information is there, accessible for customers when they need it. So we've used two strategies: the instant ETL, instant event-driven push, but also only looking at delta changes in the databases, or the source databases, when the ETL is actually happening.
Cool. Yeah. So that makes a lot of sense. Could we let's go from like beginning to end. Like, can you like basically draw like what the architecture looked like before, and then like what the architecture looks like now, I guess, with Airbyte in. And can you kind of like speak to, I guess, what tuning you did, and like what performance improvements that that you saw with this? And do you have any like suggestions for I guess the audience about if they were trying to kind of like implement if they were trying to like implement a reference cache, like are there any like pitfalls, or are there any like specific things that you'd kind of like recommend them to take when architecting a system like this?
Yeah, I was going to see if I can share my screen actually, because I've got. There we go. So I'm just sharing my screen, and this is actually what we had in place.
Mm-hmm.
It shows that we have a ton of services such as contracts, deliveries, inventory, ownership, and other stuff, invoicing, and they were doing direct calls, not via API to our reference data. It was direct calls to the database. So that's a huge problem, right? So
Yeah.
if for example the reference services just went down, then all of a sudden the APIs themselves, the deliveries wouldn't have access to that information anymore. So there was this tight coupling there, and uh, even if we separated the database out and made the API separate, still would cause that problem, because if the database goes down, then the caches aren't there anymore. So what was happening was each of those contracts, deliveries, inventory was directly reading from the source data database. Obviously not very, very good. So what we went for was this approach. Well, how do we actually put in place a way to grab data from point A, being the reference source, and push it in some sort of periodic way to each of the deliveries and other third-party services as well, and allow that to actually make it easy for them. That way, there's a copy of every single bit of data that's needed at a cache level at each of the microservices, and the microservices are then acting independently of each other, which is actually quite good. So even if the reference data falls down, the database dies, there's a cache that exists at the deliveries or the inventory or the ownership or the invoicing service layer, which
Yeah.
allows them to still operate. So you can still have the function operating and still operating completely independently. While it's using slightly old data, it just means that anything new from a reference perspective just won't show up, or just won't show as full augmented information. To help with that, the initial cache load, obviously, it's going to take a bit of time. It took, I think, about 20, 25 minutes for a full data sync to happen because
Yeah.
of the size of the data that we're working with. Um, but ever since then, it's been Delta updates, and it's been about 2 or 3 minute synchronizations.
Awesome. So I guess another question I'd have here is, um you kind of have a lot of you have a lot of like ETL connections, you have a lot of Airbyte connections, moving to, I guess, each one of these reference caches for like
Hmm.
uh each part of your architecture. They have you ever considered using, like, I guess, kind of like any type of like orchestration platform to I guess manage these syncs? Because currently it seems like you just have like this like 5 minute sync that's going, like, but you said the reference data is like updated maybe twice a day. Like, have you ever, like, do you have any kind of orchestration in place for
Yeah,
this?
so let me put a little bit of context. Like, the reference data is updated a few times a day, but we just don't know
Mhm.
when, right? So
Got it. Yeah.
there's no like specific date or time it gets updated. Um, we have been thinking about orchestration platforms because you alluded to one thing. We are running small servers to host the Airbyte servers themselves. Um, I think it would be good to get to a point where we have a set of orchestration services in place that maybe spin up and spin down servers as we need them, and even just have like a Kubernetes clusters that allow us to do that. Um, and that's actually on our roadmap for the next 12 to 18 months to move to that. For us, the first use case was, does this actually work and help performance and trust and data? And it does. And even with our current setup, we're running, I think, more than a dozen small servers of Airbyte, for example. That's still more manageable for us and easier and cheaper than it is to still warrant us to move to a full orchestration approach. Though moving to that obviously is going to help us quite considerably as we start scaling. So that is something we are already considering.
Awesome. Yeah, that makes a lot of sense to me. I guess this all kind of, the way that you describe it, it all seems kind of like it seems like it was pretty straightforward. But like, what was probably like the kind of like the biggest challenge in setting this up? Because I assume that there was probably some like some place where some things that you ran into that kind of made this, I guess, all difficult to set up because there's like kind of like a lot of moving parts here.
Um, honestly, Abby, it wasn't actually that difficult, to be quite frank. I think the hardest part was actually explaining to the engineering team the concept and saying, hey,
Really? Okay. Yeah.
why isn't this being done in the first place? Like,
You're
why
making
isn't
it you're making it sound like I set up this question to
no, I know, but like
yeah.
it's honestly it was ridiculously simple, and
Yeah.
I think that was the, I guess, funny part about it, because when you think about, like, I was actually having this conversation, like, a single conversation with one of my junior engineers yesterday. So the best engineers are able to make simple things work very effectively, and simple code is always better than something that's hyper complex. And I think that's the beauty about this approach we took. It actually was quite simple from what it turned out to be. It didn't need to be overly complex. And because of simplicity, we can actually identify particular issues. I've got my dogs running around like that. So um, that was quite simply the hardest part. It was actually helping our junior engineers understand why this was good for talent over you guys.
Yeah, you got your dog running around the yeah, that makes I think that's kind of huge, honestly. Just I having like I guess a having like basically this ETL product that's not only just I guess simple, I guess what do you call it? That's not only kind of like simple to implement, but also like I guess simple to I guess explain the value to I guess your team. But I guess like the main question is I guess another question would be like I guess this would work with a lot of different ETL providers. Like why did you end up choosing Airbyte, and why was like why was that and
Yeah,
how did
look,
you settle on that? Yeah.
um, I'm a huge fan of open source. So for me, I, I want to have control over the movement of data. Data is quite a sensitive information, not just for us, but also for most businesses. We're a financial services business, and as a service that's providing this, we need to make sure the um, ownership, the sovereignty, and the access of this data is cared for. Um, I didn't want to go through third-party tools and pushing out sensitive information from one service to another, into another third-party service. Like that, obviously, is not acceptable for me. So we needed that to be on premise, so to speak, or on our own cloud. So that was actually the biggest. That was actually the biggest reason for why we did this.
Oh well, Jins is figuring that out. I actually don't think that. I think the chat questions aren't loading for me because I think the platform I don't think the questions are loading. So I think I'll have to continue asking you questions. There's kind of just this bar spinning. Um. So yeah, I guess I guess that makes a lot of sense to me. Like I guess in terms of like in terms of like adoption, like uh where do you see I guess not adoption, where do you see your architecture growing, right? Where do you see where do you like is there innovation that needs to be done yet, or is there like or is it kind of just like a finely tuned machine now that's kind of just chugging along? Like if there was like innovation within this architecture and this reference architecture that you've set up, where does it go from here, I guess, for
Yeah,
AgriDigital?
the innovation I would like to see is actually being able to have real-time syncs through like an ETL tool. So we've got like capture CDC on sort of Postgres databases, and that allows at least real-time. That would be the ultimate outcome for us, is being able to use ETL tools, whether it's Airbyte or any service, to have that real-time data sync be pushed across from one place to another. Because that removes completely for even any endpoint calls or third-party calls, and you've got this like single customer data view that we want to have, and that's something that I've been wanting to push for so long, and we've started to really have that. We're now able to have a true single data view of the customer, because we started using this concept not just for reference data, but for like quite literally, how do we amalgamate all of our data from all of our multiple products that we have in market, plus the behavioral event data that we're capturing inside all the applications, plus any third-party data. How do we like grab all that data and pull it all into one place and quite literally have a single view of a customer and say, this customer is using the product in ABC, we can see these things. The risk scoring as a result is now affected either positively or negatively. We can do that right now, and that's been quite amazing. However, it is in real time. It's still at least a half a day delay, and that's because of the size of data that we're trying to synchronize from all the different sources. So I would love to get into a position where ETL tools facilitate that, and an architecture that allows me to get to a point where it is real time, which I think is the nirvana for all businesses, right?
What? Sorry, can you repeat that?
I think that's the nirvana for all businesses, is having real time data about their customer.
Yeah, I mean, like, I guess if you were to like, I guess, see something like do you see that like reasonably happening in the next few years, and I guess what steps would we need to take to like reasonably get there?
Yeah, I 100%. So our goal actually by the end of the year is to have that real-time data feed, like customer data profile for all of our customers by the end of the year. And so like that's the reason why one of the biggest challenges or the objectives for the technology and engineering function here at Digital is, how do we do this? Like, what architectural changes do we need to make? How do we like maybe improve or facilitate additions to the Airbyte connectors program and all that type of stuff to allow us to do real-time data synchronization across all of our data sources into our warehousing? That's our big challenge for the year. So maybe in a year's time, I can share with you the solution we come up with.
Awesome. Yeah, and I guess is there anything else that you kind of wanted to talk about in terms of like the architecture? Anything that you'd like to, I guess, recommend in terms of, I guess, what you did, or to, I guess, the audience, or in terms of like, I guess, like in general practice that you found was really useful to you?
Yeah, look, I think it's interesting because like I've worked with another fashion tech business as well, implementing Airbyte so that they could do centralized analytics. And what I realized is that a lot of companies maybe struggle or don't even think about the power of how to move data can be. So giving it a go is one of the first things. Like just go and grab some ETL tools, push it all into a centralized place, if obviously you're allowed to do that from a legality company perspective. But set up what I'm calling even a minimum data stack. Like have the ability to move the data, which is your lowest point, have the ability to store it, which is your warehousing, have the ability to put some sort of visualization on top of that, which is your business intelligence. And then you've got a minimum data stack right there. And that can all be open source in its own right as well. But having that in its first place will take your business or any sub-business or leaps and bounds to be able to start analyzing higher and broader issues and questions.
All right. Well, I think it's about as all the time we have for today. Thank you so much, Jins. It's been it's been awesome talking to you.
Thanks, mate. It's been good to
I've
check with you.
Yeah, if you want to if you want to see some more content about us talking with Jins, or you want to see you want to see some of the nitty gritty behind this, we have we have a very similar, I guess, video that touches on some of the more some of the other concepts on the Airbyte YouTube channel and on our website. So in any case, thank you so much, man. It was great talking to you.
Thanks, guys.
All right.
See you, mate.